faithfully delivering value, interpreting the world's great books. Hello, this is Sally's Book Club. Today, the book we're diving into is Dark Matter and the Dinosaurs. You've probably heard that the smallest particle is called an atom, and everything in the universe is made of atoms. Well, let me tell you, that's actually outdated info from before the 20th century. Now, scientists know that besides ordinary atomic matter, there's completely invisible, mysterious stuff called dark matter. Currently, dark matter remains one of physics and astronomy's biggest puzzles. David Gross, Nobel laureate and National Academy member, stated in his famous lecture, "The future of physics outlined 25 crucial questions for 21st century physics, with dark matter's nature ranking second." In 2015, an amazing dark matter pop science book emerged, the very dark matter and the dinosaurs we're exploring. In this 300,000 word work, author Lisa Randall proposes a groundbreaking theory. Dark matter may have caused dinosaur extinction. Randall, a Harvard MIT professor, Princeton's first female physics chair, and National Academy cosmologist, specializes in particle physics frontiers. She's also a public intellectual named in Time's 2,700 and 100 most influential people. To grasp Randall's mind-blowing dinosaur theory, we must answer three questions. First, what exactly is dark matter? Second, why are scientists convinced it exists? Third, how could dark matter make comets periodically strike Earth, causing dinosaur extinction? Let's start with question one. What is dark matter? Truth is, nobody yet knows. We only understand it's fundamentally different transparent matter. Let me clarify transparent here. In other words, for something to be visible to us, it's got to interact with light somehow, or else it just can't reflect light back. And dark matter, it doesn't interact with light at all. This means light can zip right through dark matter with no obstruction and no reflection. Exactly why we can never see dark matter. Besides not messing with light, dark matter also doesn't directly interact with regular matter. And so even if dark matter bumps into ordinary stuff, it ghosts right through like a phantom, leaving no impact. Therefore, we can't directly sense dark matter at all. Despite being so mysterious, dark matter is absolutely vital to the universe. Can't do without it. It can't do without it. Universe's worst end users. In fact, based on current space observations, dark matter makes up a whopping 85% of all matter in the cosmos. Plus, it plays a huge role in shaping the universe's structure, but many folks mix it up with black holes or dark energy. Actually, they're worlds apart. Like we said, dark matter is transparent and different from normal stuff, while black holes are just regular matter squeezed super small into a celestial body. As for dark energy, it's see-through pure energy that pushes things apart, probably vacuum energy. Also, dark matter clumps together under gravity. For example, our Milky Way's dark matter is thought to form a giant ball, while dark energy stays spread out evenly across the whole universe. And all right, next up, why do scientists think dark matter must exist? As we said before, dark matter doesn't directly interact with light or normal matter, so we can't spot or feel it. Now, some listeners might be totally baffled. If we can't see or sense it directly, how can you claim it's real? The answer is dark matter creates gravity, and that gravity affects ordinary matter around it. Borrowing the book's analogy, imagine walking through a forest and scaring off a flock of birds or a buck. Even though you can't see anyone around, those animals' reactions tell you there's a hunter nearby. The person generally credited as first realizing dark matter's existence was a Caltech professor. Fritz Zwicky was born in Bulgaria, earned his PhD at ET Zurich, Einstein's alma mater. Later immigrating to the US, he taught at Caltech, where he became a fitness fanatic. He'd entertain himself doing one-arm push-ups on the floor for fun. Zwicky was a pretty unlikable guy. He had a rough personality, rude behavior, even insulted his collaborators. He mocked Hubble's supporters as brown nosers, and many detested him so much they petitioned Caltech's president Millikan to fire this annoying clown. But Millikan refused. Millikan responded, I know Zwicky's crazy, but he throws out wild ideas. What if one or two are right? Turns out Zwicky got at least three big things right, including dark matter's existence. In 1933, Zwicky closely observed the Coma cluster, a giant group bound by gravity, a galactic family containing thousands of members. Zwicky's goal was measuring this cluster's mass. Generally, there are two ways to measure galaxy cluster mass. First, the dynamical method. This measures velocities of galaxies at the cluster's edge, deducing gravitational pull to calculate total mass. Similar to measuring Earth's orbit speed to calculate the sun's mass. The second method is photometry. Photometry measures light intensity from each galaxy to calculate luminous mass, since brighter light means more mass. Crucially, the dynamical method measures total cluster mass, while photometry measures only luminous ordinary matter. Zwicky used both methods to measure the Coma cluster's mass. According to then current views, all cosmic matter was luminous, so both methods should have matched perfectly. But Zwicky found dynamical measurements were 400 times greater than photometric ones. In other words, total cluster mass was 400 times the luminous matter's mass. From this, Zwicky deduced huge amounts of non-luminous exotic matter in the cluster. He dubbed this exotic matter dark matter. Though today we know his 400x ratio was inaccurate, Zwicky's discovery still opened humanity's door to dark matter. So, for 40 years, his theory was rejected until the 1970s, when someone proved it conclusively. That person was Vera Rubin, a formidable astronomer, Palomar Observatory's first female researcher. Arriving at Palomar, she found only men's restrooms, no women's facilities. So she made a women's sign, slapped it on a men's room door, and claimed it. Later becoming the National Academy's second female member, she tirelessly championed women in academia. If an astronomy conference lacked female speakers, she'd call organizers saying, "You've made a mistake." In the 1970s, Rubin made a stunning discovery studying stars orbiting galactic centers. To explain her finding, let's start with Earth orbiting satellites, something familiar. Generally, closer satellites orbit faster while distant ones move slower. This happens because closer satellites experience stronger gravity, needing higher speed to avoid falling. On the other hand, satellites farther from Earth experience weaker gravity, so they can't move too fast or they'll escape into space. Similarly, stars at the edge of a galaxy can't orbit too fast, or they'll break free from the galaxy's gravity and drift into space. In other words, according to Newton's gravity theory, stars farther from the galactic center should move slower. But Vera Rubin found that stars at the galaxy's edge don't slow down as distance increases. Their speed stays constant. This means the galaxy's actual mass must be much larger than its luminous matter, or it couldn't hold on to those fast-moving edge stars. Thus, Vera Rubin concluded that vast amounts of invisible, mysterious matter, dark matter, must exist in galaxies. Since then, dark matter has been widely accepted. Finally, the third question, why would dark matter cause periodic comet impacts on Earth, leading to dinosaur extinction? And this is the book's most core and original content. Intriguing, bold idea presentation. Author Lisa Randall and her collaborators proposed a startling theory. Perhaps dark matter caused the dinosaur extinction. To clarify the logic, let's break this into three sub-questions. First sub-question, why did dinosaurs go extinct? The answer is, about 66 million years ago, a massive meteorite struck Earth. Dinosaurs lived during the Mesozoic era, from about 225 million to 66 million years ago. For over 100 million years, dinosaurs ruled Earth. But 66 million years ago, they mysteriously vanished. Why did dinosaurs suddenly go extinct? The first to uncover this was geologist Walter Alvarez. In the 1970s, he went to Italy's mountains to study sedimentary rock. Sedimentary rock is a key rock type layered with deeper layers being older. Since it contains minerals and fossils, sedimentary rock acts like a book recording Earth's history. While reading this Earth book, Walter Alvarez discovered a thin clay layer, just 6 millimeters thick, cutting through the entire sedimentary formation. Below it, Mesozoic layers. Above, Cenozoic. Stranger still, below this clay layer were abundant dinosaur and animal fossils. But above it, nothing. Dating this clay layer became the next extremely difficult challenge. Fortunately, Walter had a powerhouse father, Luis Alvarez, 1968 Nobel Physics laureate. The elder Alvarez suggested measuring its iridium content. Iridium is extremely rare on Earth's surface, but it's abundant in space. By comparing Play's iridium levels to cosmic deposition rates, they could date the layer. The results stunned the Alvarezes. Iridium levels were tens to hundreds of times higher than expected. At normal cosmic deposition rates, forming this thin clay would take over 3 million years. Clearly impossible. To explain both extinction and iridium spike, the Alvarezes proposed a radical theory. 66 million years ago, a 10 to 15 kilometer wide meteor struck Earth. The impact released energy equivalent to millions of billions of TNT tons, over a billion Hiroshima and Nagasaki bombs, causing extinction. This is the Alvarez meteor theory. Contradicting paleontology's gradual extinction dogma, the theory drew fierce attacks, but Luis Alvarez was formidable. With physicists' arrogance, he mocked paleontologists in the New York Times as mere stamp collectors. Luis Alvarez died in 1988, but his theory ultimately prevailed. In 1990, scientists discovered a massive crater in a bay near a small Mexican town. It was precisely the meteor impact site predicted by the Alvarez team. This evidence finally convinced academia. The Earth-striking meteor 66 million years ago caused the mass extinction. Now, the second question, where did that dinosaur-killing meteor originate? To answer, the Oort cloud at our solar system's edge. Initially, everyone assumed the dinosaur killer was an asteroid, but the 1994 Comet-Jupiter collision changed everything. Since then, we've realized a comet was the more likely culprit. Picture comets as giant, dirty snowballs from distant cosmic neighborhoods. Beyond Neptune's orbit, solar wind, streams of charged particles, vaporizes their ice when near the sun, creating million-kilometer tails. Thus, after enough solar orbits, solar wind completely destroys comets. Here's the puzzle. Our 5 billion-year-old solar system still has countless comets. Why haven't they vanished? In 1950, Dutch astronomer Jan Oort proposed the solution, a vast spherical gas cloud at our solar system's fringe, the Oort cloud, held by solar gravity. The Oort cloud weighs only approximately 5 Earth masses, but acts as an infinite ice reservoir, constantly generating new comets. That's why our solar system still teems with comets today. You might wonder, how far does the Oort cloud actually extend? The answer is mind-blowing. 1 light year, meaning light from Earth takes a full year to reach the Oort cloud's edge. To this day, astronomers haven't found direct evidence of the Oort cloud, yet scientists universally believe it must exist. Generally, comets in the Oort cloud stay obediently in their orbits, but under special circumstances, some get restless, break orbit, and head toward the inner solar system. The inner solar system means the region inside the asteroid belt. Lisa Randall believes the dinosaur killer was a massive comet that broke orbit and plunged into the inner solar system. Third sub-question, why do some comets break orbit and head inward? Answer, they're disturbed by a dark matter disk in our galaxy. First, let's cover our Milky Way's basic structure. Observations show ordinary matter forms a flat disk, with our solar system orbiting a supermassive black hole at galactic center. It takes about 240 million years for our solar system to complete one galactic orbit. Simultaneously, our solar system bobs above and below the galactic plane every 32 million years. To visualize this, imagine the galaxy as a giant whirlpool and our solar system as driftwood in it. This driftwood circles the whirlpool's center, taking 240 million years per loop. It also bobs up and down on the sea surface every 32 million years. Now, here's the key point. Lisa Randall hypothesizes special dark matter in our galaxy. While normal dark matter forms a spherical halo, this special kind forms a thin disk like ordinary matter. This dark matter disk overlaps with the ordinary matter disk, creating a dual disk structure. As mentioned, our solar system bobs vertically through this plane. In doing so, it repeatedly passes through Randall's proposed dark matter disk. When nearing that disk, its dark matter's gravity disturbs Oort-Cloud comets, knocking them off course. In other words, dark matter can yank some comets out of the Oort cloud and fling them toward the inner solar system. In Lisa Randall's view, this is the real reason Oort cloud comets break orbit and head inward. You might be wondering about that. Is this theory claiming dark matter causes comet derailment actually legit? Believe it or not, Lisa Randall actually found evidence for this theory. She tallied impact craters bigger than 20 kilometers on Earth over the past 250 million years. Then she found these craters appear periodically with a cycle of exactly 32 million years. In other words, large meteors visit Earth every 32 million years, matching her theory, meaning Randall's idea, whether right or wrong, at least holds water. Finally, let me sum up Lisa Randall's dinosaur extinction theory. The solar system's like driftwood bobbing on the sea, vertically oscillating with a 32 million year cycle. This way, the solar system passes through a special dark matter disk hypothesized by Randall. When nearing this disk, dark matter pulls comets from the Oort cloud off course and hurls them inward. This causes large meteors to strike Earth every 32 million years. One massive meteor, 10 to 15 kilometers wide, hit 66 million years ago, releasing energy billions of times greater than Hiroshima and Nagasaki bombs combined, wiping out the dinosaurs. In fact, Randall's dark matter extinction theory is still just a hypothesis, not yet accepted by mainstream astronomy. Who the real culprit behind dinosaur extinction is still awaits human exploration regarding dark matter and dinosaurs. That wraps up our interpretation of this book. Reading notes are below the audio. See you tomorrow. End.